Matrix Rain is one of the most iconic, unique and recognizable effects. Do you want to feel like a hacker today? Then join me and let's use our coding skills to build it completely from scratch with HTML, CSS, JavaScript and object-oriented programming. In this class, we are diving deep into the code to unlock the secrets of canvas animation and creative coding to make sure we really understand how it works under the hood. Sometimes web animations are more fun with colors. HTML Canvas offers two built-in methods to draw gradients. createLinearGradient takes 4 arguments, starting x and y coordinates and ending x and y coordinates. It will create an imaginary line between these 2 points to determine size and direction of linear gradient. createRadialGradient takes 6 arguments, x and y of center point of the inner circle and its radius, and x and y of center point of outer circle and its radius. Gradient will be drawn in the space between these 2 circles. Let's use it in a project. The original effect is made out of collection of mirrored Japanese katakana characters mixed with flipped Latin letters and numeral symbols, but it will also work with other Unicode symbols and emojis. This effect is relatively lightweight and easy to code, which makes it a perfect project for beginner creative hackers like you and me. I set up my canvas. I create an instance of 2D context object which we can use to change canvas settings and call all built-in drawing methods. I set width and height to cover browser window and I make my canvas transparent. I can write code in so-called procedural way, where I simply declare variables and functions step by step in the order I want them to be executed. It's the most basic way to write code. In this case, I will write the code using object-oriented programming paradigm, which means I will wrap my functions and variables in objects. There are many ways to create objects in JavaScript. In modern JavaScript, we usually use so-called classes. Class is a special kind of function used to create many similar objects. Class syntax is relatively new. It was introduced in 2015 and it's just so-called syntactical sugar, simplified syntax built on native JavaScript prototype functionality. One of the 4 main principles of object-oriented programming is encapsulation, which means we will wrap variables and related functions that operate on them in objects. Encapsulation helps us to keep our code organized and also could be used to protect the data inside objects from outside interference. In this project, I will encapsulate data into 2 custom classes. The first class will be called, for example, symbol. Its job will be to create and draw individual symbol objects that make up the rain effect. The second class can be called, for example, effect. It will be the main wrapper for the entire rain effect. This is where we put all functionality to create, update and draw all symbols. So symbol class will create and manage individual symbols. Effect class will manage the entire effect, all of the symbols at once. Each class will have this special constructor method, which will be automatically triggered when we call class using the new keyword. Whenever we use the new keyword, constructor will create one new blank object and it will fill it with values and properties based on the class blueprint inside. We can also give our classes other custom methods. I will explain these as we write the code. The last piece we need is animation loop. Custom function I call, for example, animate, will run 60 times per second, updating and drawing our effect over and over to create animation. Nice! Let's write blueprint for effect class. The effect needs to always be aware of canvas size, so it can spread symbols all around the available canvas area. We will pass it current canvas width and height as arguments when we create the effect. Then we take these arguments and convert them into class properties like this. Here I'm saying canvas width property on this instance of effect class we are creating right now is equal to canvas width argument that was passed to the constructor. These arguments will be passed here when we call this class using the new keyword in a minute. You will see. Here in constructor we will have all global settings for our effect. I set font size to 25 pixels. The effect will be made out of individual columns. The number of columns will depend on width of canvas and font size. To find out how many columns we can fit in, I do this.canvasWidth from line 17 divided by this.fontSize from line 19. I will also need array that will hold all individual symbol objects. I create a method to fill this symbols array with symbol objects. I will call that custom method, for example, initialize, and I will make it private by starting its name with a hash symbol. Private methods cannot be called directly from the outside, they have restricted access. Creating private methods like this is a good example of the second pillar of object-oriented programming called abstraction. Principle of abstraction means we are hiding unnecessary details from the user. User doesn't need to know about this initialize method. I will write the code in a way that initialize method automatically executes itself when we create instance of effect class. Abstraction is about hiding internal functionality and implementation details of our objects and only exposing essential information to the user. Abstraction helps to isolate the impact of changes made to the code so that if something goes wrong, the change will only affect the implementation details of a class and not the outside code. So, the job of this initialize function is just to take symbols array from line 21 and fill it with symbol objects created using symbol class from line 6. The number of these symbols will depend on the number of columns from line 20. We have a for loop that will run once for each column, and each time it will fill that index in symbols array with an instance of symbol class. By using this special new keyword, JavaScript will look for class with that name and it will trigger its constructor to create one new blank object using blueprint inside. Let's write that blueprint. Before we create each symbol, we need to pass it some values from the outside as arguments. We will need x and y coordinates, font size, and canvas height. I will have this.characters property, which will contain a long string of characters. Each time symbol jumps to a new position, it will randomly choose one of these available characters. I will use these characters since I'm trying to replicate matrix rain effect, but feel free to use any custom set of characters you want. It will also work with Unicode emojis, which could be interesting. If you want to use the same characters I'm using, I will make them available somewhere in the description down below, so you can just copy and paste it. Now I just convert these arguments into class properties. This.text is going to be the currently active symbol, so value of this.text will be a random number from this.characters string from line 8. We will write that logic inside draw method in a minute. Each symbol object created by this class will have access to public draw method. This is a custom method, again, so you can call it whatever you want. The job of this method will be to randomize current character and draw it on canvas at a specific position. Every time draw method is called, it will choose a random symbol. So this.text from line 12 is one random character from these. I pick a random one by taking this.characters and calling characterAdd on it. CharacterAdd is a built-in JavaScript string method. It can be called on string data type. Characters on line 8 is a very long string. CharacterAdd built-in JavaScript method takes a single index argument and returns a new string containing only that one character located at that specific offset of the string. So here in brackets, I need to pass it a single number between 0 and length of this.characters string. We need numbers, so first I call math.floor to remove decimal points, and it will be a random number between 0 and this.characters length, like this. All this just stands for one number. If the result is 1, we get this character. The first character in the string is index 0. Index 20 will give me this character. Index 35 will give me this one. I think you get the idea. So now we chose a random symbol from all available characters. Let's draw it on canvas. I pass context argument to my draw method so that I can specify what canvas I want to draw on. I take that context and I set its fill style to green. Or maybe this shade will be better. Now I call built-in canvas fill text method, which takes 3 arguments: text we want to draw and x and y coordinates where I want to draw it. I pass it this.text, which contains one symbol we just randomized, and I will draw it at this.x and this.y coordinates. The way I want to write this effect is that this.x and this.y will have to be multiplied by current font size to make all the characters and symbols sit nicely next to and below each other. If I change font size, the effect will automatically rearrange itself to accommodate for larger or smaller font. The characters will be falling down, so when they reach bottom of canvas height, I will reset them back to vertical position 0 up top. Else, we just increase y by 1. Since I'm multiplying y times font size, they will jump in steps equal to font size with no overlap. The next symbol will be drawn below, depending on font size. Perfect, our symbol class is complete. We have a blueprint that will be called every time we call this class with the new keyword, and all objects created by this class will have access to this custom draw method, which will randomize, move and draw symbols. I go back inside initialize method on effect class. Here I'm running a for loop that will fill symbols array with symbol objects, depending on number of columns we have available here. For each column I create one symbol that will be falling down, as we just wrote that logic inside draw method. On line 7 I can see my symbol class expects 4 arguments coming from the outside. Horizontal x-coordinate will be index from that column. I want them to start falling from top, so initial vertical coordinate will be 0. Font size will be this.fontSize from line 31, and canvas height will be this.canvasHeight from line 30. Nice! Let's create an instance of effect class. Constant variable I call, for example, effect is equal to new effect. And on line 28 I can see it needs canvas dimensions, so I pass it canvas width from line 3 and canvas height from line 4. Inside animation loop I will set built-in canvas font property. The font property specifies the current text style, and I set it to effect.fontSize. Referencing class property we declared on line 31 plus pixel monospace. Monospace fonts have characters that occupy the same amount of horizontal space. Now I take symbols array from line 33 and I call for each on it. I call each element, for example, symbol, and for each symbol I call their associated draw method from line 15. I can see it expects context as an argument, so I pass it ctx from line 2. Now I call built-in request animation frame method and I pass it animate, the name of its parent method. This will create endless animation loop. I need to trigger the loop by calling animate like this. Nothing is happening just yet. It's because symbols array on line 33 is still empty. I wrote initialize method that fills it with symbol objects, but I haven't called that method anywhere. As I said, we want to use abstraction here, so this private method is not directly accessible from the outside. We are hiding inner workings of our object from the user. I will call this method inside constructor like this. I'm calling private method from inside constructor. As we know, constructor is called when we instantiate class by using the new keyword. This way, initialize will be automatically executed when I instantiate effect class here on line 43. I can console log symbols here, like this, just to check. It's still empty, so there must be an issue with this for loop somewhere. Why is it not filling my array with objects? It's because this .columns is a number, so there is no need to use .length here. And we are drawing symbols. Well done! Click like if you are getting any value. I want the old symbols to slowly fade away, so I will draw semi-transparent rectangle over canvas for every animation frame. I set fill style to RGBA 000, which is black, and opacity 0.05. I call fill rectangle and I draw it across the entire canvas. Color needs to be in quotes, it's a string. Nice! This is a useful trick to remember. If you want something to slowly fade away on canvas, just draw semi-transparent rectangle over it. Each animation frame draws new, semi-transparent, see-through black rectangle, which will cause old paint underneath to slowly fade, step by step. We don't want it to be moving like this, we want each column to have randomized delay. On line 19, I check if vertical Y position is on the bottom of canvas, and if it is, I reset it back to top. I will add one more condition here. When you call math.random on its own like this, it returns a random value between 0 and 1. So I say, if that returned random number is more than 0.5, only then reset the column. That breaks it down a bit. How about 0.7? Now we are starting to see bigger differences between columns' vertical positions. 0.9, 0.95, let's go with 0.98. Nice! The effect is moving very fast. I can slow it down in multiple ways. What if I want to control frame rate? I want to have a variable that defines frames per second, and I want animation to adjust itself to that frame rate automatically. We can do it by using timestamps and delta time technique. We use frame rate to calculate how many milliseconds each frame should last on screen, and then we calculate delta time to control animation speed. Delta time is the difference between frames in milliseconds. Let me show you and explain. It's simple. I need a variable that will keep track of last time, of timestamp from the previous animation frame. I will compare it to the current timestamp, and the difference between them is delta time. At first I set it to 0. I need a variable that will set FPS. Let's say I want the animation to run at 30 frames per second. Next frame variable will be the amount of milliseconds we wait until we trigger and draw the next frame. I want 30 frames per second, so 1000 milliseconds divided by FPS, which is currently set to 30. Timer will be a variable which accumulates delta time. When it reaches threshold defined in the next frame, it will animate the next frame, reset itself to 0, and it will start counting again. Nice. How do we get the current timestamp? RequestAnimationFrame method has a special feature. It automatically passes a timestamp argument to the method it calls. So Animate will have access to this auto-generated timestamp argument. I will assign it a variable name here. I will just call it timestamp. Now we need to calculate delta time, which is the difference in milliseconds between previous animation frame and the current animation frame. I calculate it by taking the timestamp that was just passed here minus the timestamp from the previous frame, which I will be saving in last time variable. When we calculated delta time, we will assign last time to the new timestamp so that it can be used for the next loop. Now we have delta time. We know how many milliseconds it takes for our computer to serve the next frame of animation. I can use it to time frame rate. I say if timer from line 48 is more than the next frame from line 47, trigger all this drawing code. Trigger next step in animation, and also I need to reset timer back to 0 so it can start countdown to the next frame again. Else we just increase timer by delta time, we don't animate anything, and we just wait until timer is high enough. So this is how you use timestamps and delta time to control frame rate. One important thing to keep in mind is that this timestamp is auto-generated by RequestAnimationFrame. It means that we will only have timestamp for the second loop. The very first loop is called from here, and there is no auto-generated timestamp, so I have to pass it some value. Let's pass it 0. Now my animation is running at 30 frames per second, 15 frames per second. I think for this particular code rain effect it's better with lower FPS, which also makes the effect more lightweight, because we don't have to draw it so often. You can see that Japanese alphabet characters have different horizontal alignment than Latin characters. We can fix that by setting text align canvas property to center. Now it's more even. Things like fill style and text align are global canvas properties. Once assigned, they will apply to everything drawn on canvas element until they are reassigned to a different value. For performance reasons, we should try to write our code in a way so we don't override these values very often. Here I'm declaring them once per animation loop, which is fine, but here on line 17 I'm setting global fill style property on my canvas every time I call draw method, which runs for every character in symbols array for each frame. We can reduce the number of calls by removing it here and declaring it here instead. So now, instead of redeclaring it over and over for every symbol, I'm just declaring it once for all the symbols in the array per frame. I just have to be careful about the order here. I declare fill style here, I draw the semi-transparent rectangle to get fading trails effect, then I set global fill style to a different color, and that color will be used to draw all my symbols. Perfect. I can increase frame rate. Since we are serving the next frame by using built-in RequestAnimationFrame method, it will have a cap. In most modern browsers, RequestAnimationFrame automatically adjusts itself to screen refresh rate. Unless you have a high refresh gaming screen, your refresh rate should probably be somewhere around 60 frames per second. When I resize my browser window, the effect doesn't adjust itself automatically. How can we make it responsive? It's easy. I create event listener for window resize event. Whenever resize event is triggered, I set canvas width and canvas height to new width and height of browser window. Nice, that works. Canvas is resizing. I want to spread the effect across the new available area, so I will have to recalculate number of columns we have available. because it depends on canvas width and font size. We set canvas width at first here on line 28 when we create instance of effect class. We can expose some of these properties and make them accessible from the outside so that their values can be updated. That way, they can be set to a new value. I do that by creating a public resize method on my effect class. This method will take new width and height, and it will set canvas width and canvas height to these new values. After we updated the values, we recalculate how many columns can fit to the new canvas width. We delete all symbol objects from the array by assigning symbols from line 32 to an empty array, and we call private initialize method that will create new symbol object for each column. Inside resize event listener, I update canvas width and canvas height, and I call this new resize method we just wrote. I pass it new canvas width and canvas height. I made a typo somewhere, let's see. Oh, here on line 46 I missed brackets. Nice. Now it works, and whenever we change screen size, the effect will automatically reset and recalculate its values to take up all the available canvas space. I set FPS to 30 frames per second. As we said before, we can create linear or radial gradient on canvas. Built-in createLinearGradient method will create gradient object. We pass it x and y of the starting point and x and y coordinates of the end point. It will create linear gradient between these 2 points, so these coordinates set direction and size of gradient. I want my gradient to go from coordinates 0, 0 to coordinates canvas width, canvas height, so size and direction of my gradient will be this. We also have to define what colors we want our gradient to be made out of. We use special built-in addColorStop method that can be called on this gradient object. We pass it offset and color. Offset is value between 0 and 1, 0 is start, 0.5 is middle, 1 is the end. We can add as many color stops we want in between. My gradient will have 6 color stops at 0, 20, 40, 60, 80 and 100%. And colors will be, for example, red, yellow, green, cyan, blue and magenta. To apply canvas gradient, we need to assign it to fill style or stroke style property. Important thing to understand is that gradient is not applied to individual shapes, but to the actual canvas element, so basically to the background. It means that individual shapes, letters and drawings will take different gradient color depending on their current position. They will change colors as they move over different areas on canvas, based on size and direction of gradient we defined for the canvas element. As you can see, my gradient is going from top left to bottom right corner. I can change its direction by swapping around these values. createRadialGradient has always been a little bit confusing for me, because if you give it wrong values, it will create strange shapes and blank canvas areas. It was never very intuitive for me until I took time to properly read documentation. It's actually simple as well, let me show you. It takes 6 arguments, x and y of center point of starting inner circle and its radius, and x and y of center point of the outer circle and its radius. Gradient will be drawn between these 2 circles. I want my gradient to be exactly in the middle of screen, so center point coordinates of inner circle will be canvas width divided by 2 for horizontal position and canvas height divided by 2 for vertical position. I give my inner circle radius of 100 pixels, for example. Outer circle will also have center point exactly in the middle of canvas and its radius will be 200 pixels. Nice! We have radial gradient here. I make the outer radius a larger value. Even larger. The gradient doesn't have to be symmetrical. Inner circle can have center point that is off to the side, like this. Just be careful, if you give the inner circle values that position it outside of the outer circle, you will get very strange behavior. I think because of this, radial gradient can be confusing for some coders, but now you understand it. If you have any questions how to apply gradients to your canvas effects, let me know. If you understand how gradients work after watching this video, I would also like to know. You can leave a quick comment that just says +1, since you added one new skill to your creative coding toolkit today. If you want to make your gradient effect responsive, we also have to include it in window resize event. I just take all this code and I put it inside my event listener. Notice that I'm not redeclaring this let variable, I'm just reassigning it to a different value. Every time Canvas changes size, the gradient will adjust itself to make sure it's centered. Do you want to discover more creative coding secrets? Check out some of these free courses. I'll see you there.